4.5, you're going to look at graphing rational functions. Rational functions are basically functions that are fractions. And just like you got to use the Desmos app before, you get to use the Desmos app today. Okay, this is going to be kind of confusing at the beginning, but you'll understand what a horizontal and vertical asymptote is. So what does f of x equals 1 over x graph looks like? It looks like this. Okay, so basically the vertical asymptote is x equals 0. Everybody see that right here? It's a vertical line at x equals 0, and on the test, don't forget the x. That means that this line is getting closer and closer and closer to x equals 0, but it won't touch it. There's also a horizontal asymptote at y equals 0. And you can see that they get closer and closer and closer, but they don't touch it. Okay, so how do you find the vertical asymptote on any fraction function? All you do is you set the denominator equal to 0 and solve. Okay, so I'll show you some examples on the next couple of pages. How do you find the horizontal asymptote? You take the highest power in the numerator and divide it by the highest power in the denominator. That's how you find the horizontal asymptote. There's going to be 3 scenarios. 3x plus 2 divided by x minus 2. X plus 2 divided by x squared minus 8. Or x squared minus 3 over x plus 1. Okay, these are the 3 different scenarios for your horizontal asymptote. If you take the highest power in the numerator, 3x, and divide it by the highest power in the denominator, which is x, notice that the powers are the same, so they cancel out. So your horizontal asymptote is y equals 3. And do not forget the y, because remember, our horizontal asymptote is a line, so don't forget y equals 3. So that's one scenario. The second scenario, the highest power in the numerator divided by the highest power in the denominator, which simplifies to 1 over x. And then what you're going to do is, as x keeps getting bigger and bigger, let's say x is 100, let's say x is 1,000, let's say x is 10,000, 1 over 100, 1 over 1,000, 1 over 10,000. It's always going to get closer and closer and closer to 0 if the power in the bottom is higher than the power on the top. And then the last one, highest power in the numerator divided by the highest power in the denominator, which simplifies to x over 1, which is equal to, x keeps getting bigger and bigger. It's not getting closer and closer to anything. This one has no horizontal asymptote. So those are the 3 scenarios to find the horizontal asymptote. Either the powers are the same, and you actually get a number. The one on the bottom is smaller than is bigger than the one on the top. It goes to y equals 0. Or the one on the top is bigger than the one on the bottom. No horizontal asymptote. So here we go. Let's do a few examples. It looks like we're going to do 3 examples, so you'll catch on. Graph the function and find the horizontal asymptote and the vertical asymptote. And you're going to use your decimals to also help you graph it. Okay, so in order to find the vertical asymptote, all you do is you x plus 3 and you set it equal to 0. So x is equal to a negative 3. That's called the vertical asymptote. It's where the denominator can't equal 0. If I put a negative 3 back up there, it's going to be 0. So it's where it can't equal. So you have a vertical asymptote at x equals a negative 3. To find the horizontal asymptote, you take the highest power in the numerator and divide it by the highest power in the denominator. And they are exactly the same power, which equals y equals 1. This is the vertical asymptote. Horizontal asymptote is at 1. And if you use your Desmos, button and you graph it, it's going to get closer and closer to this, and it's going to get closer and closer to this horizontal and to this vertical. And that's why they're there. I don't want you to do this and then just go like that. They're there so that you get closer and closer to that one and closer to that one. So that's why there's horizontal and vertical asymptotes. Okay, let's do another one. To find the vertical asymptote, you take the denominator and you set it equal to 0. So x is going to equal plus or minus 2. You have two vertical asymptotes. So on your graph, I need to see a positive 2 and a negative 2. Vertical asymptotes. Okay, to find the horizontal asymptote, you take the highest power in the numerator and divide it by the highest power in the denominator. And you're going to get 2 over x. And as x is getting bigger and bigger, like 100 or 1,000 or 10,000, what's 2 divided by 100? What's 2 divided by 1,000? What's 2 divided by 10,000? It's going to get closer and closer to 0. So you have another one right here at 0. And then when you put it into your Desmos, you're going to have one getting closer and closer to this vertical asymptote and this horizontal asymptote. This vertical asymptote, this horizontal asymptote. This vertical asymptote to that vertical asymptote. Final answer. Okay, one more I think and we're pretty much done. This is the same thing as 2 over x squared plus 2x plus 1. Okay, so in order to do this one, we're trying to figure out the vertical asymptote. So in factored form, x plus 1 equals 0, x is equal to a negative 1. If x equaled a negative 1 in the denominator, it'd be undefined. Horizontal asymptote, you take the highest power in the numerator and divide it by the highest power in the denominator. And as x keeps getting bigger and bigger, 2 over 100 squared, 2 over 1,000 squared, it's going to get closer and closer to 0. And here is what the graph's going to look like. You put a vertical asymptote at a negative 1. You have a horizontal asymptote at 0. And it looks like this. And you are done. So use your Desmos and use the definition of horizontal and vertical asymptotes.